Okay, so basically, we've got the exam coming up at the end of this week. So tentatively what I'm thinking of doing, I have different sections on different days, so this might not make a lot of sense for this section, but I'll make the exam available Thursday at around 5 o'clock. I get back from a class at 4:45, so I'll probably, actually I can set the release date to be kind of a little bit earlier, so it might be released at like 4 or something. Now, I wouldn't suggest taking it Thursday because we still have a class Friday in which I'll do some review. So for us, it probably makes a little more sense. It'll be available from like Thursday late afternoon all the way through the end of the day on Sunday, okay? So you can take it at any time during that, a little more than 72 hours, right? Kind of for us, probably thinking what makes the most sense is taking on Friday after we have class. Or if you want to wait, I try to think about what I did in college, and Sundays were usually like a day where I had to catch up and study and get projects done. If you want to take the day Sunday to study for it and kind of take it at any point of the day Sunday, that way you have that option over those 3 days as opposed to just me saying, take it sometime on Friday, right? So just giving you a little more flexibility. So once you kind of start the exam on Canvas, which is where it will be, you'll don't have it exactly kind of completely worked out yet, but it'll be anywhere between an hour and 15 and an hour and 30 minutes, right? Kind of depending on exactly which questions I end up kind of cutting. I've got, so I'm still kind of finalizing it, but it should be, roughly somewhere between 15 and 20 multiple choice questions. And then I'll have 1 or 2 short answers at the end, right? Now, when I say 1 or 2, they'll include multiple parts, which is why I say 1 or 2, because I may just kind of combine it all into one short answer that might have like A, B, C, and D. Or I might do like kind of split that up into 2 questions where it has like 2 or 3 parts, right? So the short answer questions, you basically upload something that shows your work. So this can be pictures, this can be scanned PDFs, this can be a Word document if you really want to type out all of your work. Now, I wouldn't suggest doing something like a Word document because it's probably, you don't just want to show me your answer. I want to see your work. So on those short answer questions, I can give you as much partial credit as possible. The kind of 15 to 20 multiple choice questions, like I can't give any multiple choice. I can't even give any partial credit for, right? So you don't have to show your work for those, only for the short answer, okay? Yeah, usually people will upload pictures. You can do the work in Excel. That's also, you can upload an Excel document for those short answers as well. I'm not going to use like a lockdown browser in the sense that you can't open other applications. So you can use kind of any, you could open up some of the slides that we have. You can open up previous problems. So that means that's probably going to be a little bit more difficult than if I had you take it like in person in class. But you'll have a lot of resources available to you, okay? So when you're looking at these practice exams, it'll look very similar to the practice exams. I may make it just a little bit, some of the problems might be just a little bit harder because you do have a couple more resources available to you as opposed to kind of taking it in person in class and being kind of restricted to just our, 50 minutes, right? You'll have that formula sheet. So we go here. I think I already have it pulled open. Right now, if you're looking at this on Canvas, I can't remember if I mentioned this in this section. Let me get rid of this out of the way so I don't have to keep looking at that. If you go to Files, the Practice Materials, just click here. Sometimes we'll see if it does it on my web browser. Yeah, I don't know why it does this. Something about the compatibility issues with Canvas. If you download the formula sheet, this is what it ends up looking like, right? So don't use it off the web browser. Now, as we work through some problems today, and then like I said, we have a study day Wednesday, so you don't have to show up. I can't mandate that. I'll be here filming another kind of review, working through some practice problems. So if you want to be here or you want to sign a Zoom, that's it. You can do that. I'm just not telling you have to. Okay. And then Friday we'll do some more. And as we kind of work through the problems, I'll kind of point out what different formulas mean. I always suggest a really good study tool going into this exam. Maybe print this out and start writing next to the formulas exactly what they mean. Right. And then if you do that work, right, put in the extra effort, you can have that formula sheet when you take the exam, right? So writing down what these mean ahead of time, I think would be a huge benefit to most people. Okay. Let me think if there's anything. Oh, one more thing I want to mention, and I'll put this in the description of the exam. and I'll mention it again probably several times this week, I don't know why. Well, I can take some guesses why, but Safari is not very kind when it comes to Canvas. So when I'm writing these exams in Canvas, formulas, different kind of these symbols and Greek letters I'm using, occasionally Safari doesn't like them and it just shows up as blank, right? So do not use Safari. I would suggest kind of the order I would say is Google Chrome, Firefox, and then Internet Explorer, right? I haven't had anyone really have any compatibility issues with any of those, but I'm usually typically using Google Chrome, so I know if I can see it, that if you use Google Chrome, you'll be able to see it as well. But for whatever reason, that Safari has some issues, okay? Other than that, are there any kind of questions for me after that about the exam or anything related to kind of homeworks or anything like that coming up?
Is the test required lockdown browser?
So I said no, so I won't be using lockdown browser. Get on, like I said, you just have that hour, 15 hour, 30 minutes. Once you start, you can open, Microsoft Excel. You can use these other applications, so you won't have to use that lockdown browser. Any other questions for me? I thought maybe I saw one that's okay. For showing our work in Excel, yeah. If you're doing the short answer, showing your work, that would be I can observe the formulas, right? So once again, I think I mentioned this with the homeworks. Make sure when you're uploading these Excel files that you can see when you click on the cells. Like I would suggest, download it, upload it, and then download it for yourself to make sure once it's downloaded, you can see still those formulas in the cell. Okay. And I think some of the issue might be Safari there as well when you're uploading those for kind of making it so that you can't see the formulas. Okay. Any other questions before we get started for today? Nothing in the chat. All right. So probably pick and choose. We'll kind of start with this practice exam. Oh, that's the answer key. We'll start out with practice exam A. Now notice for the answers, I don't kind of show any of the work. If I recall, on practice exam B, I don't have the work there either. Well, I'll upload another file where it kind of shows how to work these out so that if we don't get to go through every single problem, you'll kind of see how we work them out and not simply have kind of what the correct answer is. Okay. But for today, let's start with practice exam A. I'm not going to start from the beginning because I think, I want to make sure that we get through the harder problems first. So let's go down here. But I still want to do a little bit of a review. So let's go back to kind of looking at some probability stuff. So let's start with problem 5. Okay. So it starts out, and this is kind of the way that the exam will flow as well, is I might give you some information and say, use this for the next 5 questions. Okay. So we're going to be using this table for the next 5 questions. So on number 5, let me, so we can see this all a little bit better. We're going to use this contingency table that gives us kind of these 2 events. So whether or not someone wants legalized or marijuana legalized or not, and then whether or not they're age 55 or older or not. Okay? So remember, kind of the total columns tell us the probabilities of whatever the events are on the row and column heading. So the probability someone is 55 or older, if we selected someone at random, would be 0.25. Right? The probability they don't want marijuana legalized would be 0.34. We then said these top 4 left cells, right? I guess maybe to kind of make this all look the same. These top 4 left cells all represent the intersections of whatever the row and column heading are. So the probability someone's 55 and older and wants marijuana legalized is 0.14. Okay? So that's just kind of a little bit of a review of these contingency tables. So what would the missing value of X be in this contingency table? Well, how did we say first of all, which of these can I rule out right away? If I'm looking for a probability, yeah, 1.27. I can't see anything outside the range of 0 to 1. Right? So right away, I now have a 1 1/3 shot if I'm just guessing, just from simply remembering that principle. So on these multiple choice, I think sometimes students don't like multiple choice questions because they seem, or they well, if I get it wrong, I get concerned. But on a multiple choice question, simply remembering the principles can allow you to kind of rule this out and make, even if you're guessing, give you a lot better chance. Whereas on a short answer, knowing those principles don't get you any closer to kind of being able to work through the problem, right? So we can rule out D, but how can we find X. Well, if we remember, how do we find the totals here? Like, let's say I left off this entire total column. How could you reproduce those totals? Yeah, add across the rows, or if I had deleted these, add down the columns, right? So notice 0.14 plus 0.11 is 0.25, which means 0.52 plus X should be equal to 0.75, right? So instead of kind of switching, because it wouldn't really have to write a whole lot here, what we have is 0.52 plus X is equal to 0.75. Now from here, just a little bit of algebra, right? Subtract 0.52 from each side so that we would have X is equal to 0.75 minus that 0.52, giving us that 0.23 value. Okay? So X there would be 0.23. Okay? Any questions on that? Like I said, something else I maybe could have done, we'll use a different letter here. What if I had left that out? How would I find what Z is? 0.14 plus 0.52 would have given me that 0.66, right? Or Z, if I had left that part out, okay? Any questions on that? Shouldn't be too bad. This should hopefully be an easy one if I asked you this on the exam. So what's the probability a person is 55 or older and they do not favor the national legalization of marijuana, right? So if I'm looking for an and, right, what I'm really thinking about there is the probability of an intersection. We said the top four cells represent the intersections. So the probability someone is 55 or older and they do not, right, favor legalization. So that would just be this cell right here or that 0.11. So that one, I mean, there's no real work to do there other than being able to interpret that and kind of use that contingency table to find that intersection. Okay. So hopefully those are some easier points in the exam. Now we'll get to some maybe a little bit more difficult things. Right? So given that a person believes in the legalization or wants the legalization of marijuana, what's the probability they are 55 or older? So let's think first about what we want. So I'm going to switch over here. This might take a second. Let's see if we can get this to show up for everybody here. 1, 2, 3, there we go. So what we wanted was, and I already forgot, I think it was given, right, that someone wants marijuana legalized, what was the probability that they were greater than 55 years old? Or you could put here, like, you wanted to write it out, you know, older than 55, right? That was our event. Okay? So here we're looking for a conditional probability. And I'll show you where we find this in the formula sheet after we kind of switch back, right? But we have the general form is that if I'm looking for a conditional probability, that's going to be the intersection of the two events divided by the probability of what I'm conditioning on. Remember, what I'm conditioning on, it's what's on the right-hand side here, okay? So if I write this out in the context of my example, right, this is my A, this is my B, I'll find the probability that someone is older than 55 and wants marijuana legalized, divided by the probability of whatever I'm conditioning on, which I was conditioning on, the probability that they wanted it legalized. Right? What this is really saying is take all the people who want it legalized and what proportion of them now are also older than 55. Okay? Well, we can find these two things from the table, right? So let's go back, and what I'll do here, share my screen. But I'll leave this up down here in the lower corner so if you're kind of still writing some things down, we'll have it up there as we look at this. So first of all, where did I get this general form of the equation? Right? If I look at this formula sheet, we'll zoom in so we can see things a little bit better here. Right? Over here on this right-hand side, oh, thank you. Give you guys a little more time to write it down then. So if we have our formula sheet, sometime today. There we go. Over here on the right-hand side, we have that the conditional probability is the probability of the intersection of these two events divided by the probability of what we're conditioning on. Okay? So that's how I got the general form of the equation to solve for the conditional probability of A. So then, if I go up here to my contingency table, I want the probability that someone's older than 55 and they want marijuana legalized. So older than 55, want marijuana legalized, so yes and yes, 0.14. So if I'm thinking about here, I'm thinking 0.14 is my numerator. And then the probability that they want marijuana legalized, so that's just yes, they want marijuana legalized, go down to the total, right? That would be 0.66. Okay. From there, it's just simply enter this into our calculator. Can't do that one off the top of my head, so I brought my calculator today. So this should be approximately 0.21. Right. Any questions on that? So if we come down here, look at all the possible answers for 7. It's approximately 0.21. Now, sometimes like in this one, let me see, I think the exact answer would have been like repeated. So if I only show you the answers to 2 decimals, then whatever you come up with, round it to 2 decimals, right? So this would round to 0.21. So that's kind of the answer that we choose. Now, I'm never going to, give you like 0.21 and 0.22 so that if you make a rounding error, you get the wrong answer. And I'm not going to never be that mean. But however the answers are displayed, that's what you should kind of round your answer to. Okay? Any questions on that one? Or we're okay with that? So there's nothing in the chat here. Okay. So here's where, maybe it's a little bit tougher because we're writing things out in the probability, or we can't just write out our events now. So I'm kind of giving you these events where O, I'll tell you up here, kind of represents being older than 55, and LM represents wanting marijuana legalized, right? So not wanting marijuana legalized would be LM complement. Okay? So if we want these two things, right, if we're worried about, are they, first of all, let's do 8 and 9, because 9 is a lot easier, and we'll spend more time on 8. If I'm asking you, is wanting marijuana legalized and being under the age of 55, so that would be O complement, are they mutually exclusive events? Right? So the only way we have mutually exclusive events is if those two things can't happen at the same time. If they can't happen at the same time, then their intersection has to be what? Two things can't happen at the same time. The probability of seeing both of them happen at the same time would be never, which is a probability of 0, right? So what we know, we're thinking about the definition of mutually exclusive, just more generally, not in the context of this example, is that the probability of the two events, the intersection of those events, has to be equal to 0. Well, here we had kind of is being not over 55, or O complement, and wanting marijuana legalized, right? Are those mutually exclusive? Well, the intersection, if they were mutually exclusive, would have to be equal to 0. Okay? Well, if we go up here, first of all, no matter what events I asked you about, did we have any zeros for the intersections? No. So it doesn't matter which of these I ask you about, none of them are mutually exclusive, right? The only way they're mutually exclusive is if I see an intersection of 0 up here in one of these top 4 left cells, right? More specifically, what we were looking at being not older than 55, so under 55, and wanting marijuana legalized, right? So we know the intersection is 0.52, right? But simply remembering the mutually exclusive definition that it's when we see 0 intersections that have a probability of 0, well, right away we know that, note, none of these can be mutually exclusive. We have no zeros in that contingency table. So right away, we can rule out A and B. So here now we're looking at no, they're not mutually exclusive. And then we're really just choosing between, is it because the union's equal to or not equal to 0, or is it because the intersection was not equal to 0? Well, we just said they're only mutually exclusive if the intersection is 0. So here, they're not mutually exclusive because that intersection is not equal to 0. Okay? So there, even if I, just look at the table and see there's not zeros, doesn't matter which two events I'm talking about, I could have ruled it down as C and D, and then I know, well, the only way I can identify mutual exclusivity is if the intersection is equal to or not equal to 0, right? It doesn't matter what the union is, okay? Any questions on that one? So if you're watching these, and this goes to, people showing up, putting effort in and trying to do well, hint, hint, you're always going to be looking for the intersection when you're thinking about mutually exclusive events. These unions, we should have been able to rule out right away. It doesn't matter what the union is, right? It only matters what the intersection is. Okay? All right. So this one's a little bit more difficult, right? So let's think about independence, okay? If supporting the national legalization of marijuana and being 55 or older independent events. So we're thinking about event O and event LM here, right? Being over 55 and wanting marijuana legalized. So the only time that two events are not mutually exclusive, independent. Let's see if I've got, well, here's one way we can check. Right? One of the checks was if the intersection is simply equal to the probability of each event multiplied by each other. So kind of thinking about here are special conditions. This holds, right? Might be a good thing to write down next to it, or if we're kind of thinking about in the future. This only holds if the events are mutually exclusive. Why? Because the union is supposed to be the probability of both events minus the intersection. Well, if the intersection is 0, then this is what the equation becomes. So this only holds if they're mutually exclusive. And then in fact, just to kind of prove that, so we could actually use our previous example of mutually exclusive and see if that holds, right? So, well, we already know it won't, never mind. It doesn't matter for us to check because we already have talked about it doesn't. But if we had found the union of those two events and kind of added up the probability of each event occurring, we would have found that those two things weren't the same, right? So they weren't mutually exclusive. But for independence, this is the special condition that'll hold, okay? So if they are independent, this equation will hold. If they aren't independent, then these two things won't be equal, right? So let's use that one first, okay? So let's go back. We're looking at this table. What that equation, that special condition is saying is, if A and B is equal to simply the probability of each event multiplied by each other, we know they're independent. So for us, this would be older than 55 and wanting marijuana legalized. If that's equal to the probability of being older than 55 times the probability of wanting marijuana legalized, then these will be independent events. So if we look here, what's the intersection? So older than 55, wanting marijuana legalized, 0.14. What's the probability of being older than 55? We go over to the total, 0.25 times the probability of wanting marijuana legalized, which is is it 66? Yeah, 66. So if I do this math right, 0.25 times 0.66, I get what? 0.165. Are those two things equal? No, so they can't be independent. Right? Now, that's a way to check to see if they're independent. The problem is the answers that we have here, so that might be good for a short answer, but here I've got the actual definition of independence, which is that, kind of leave this up here. The actual definition is if the unconditional, right, probability of A is the same as the conditional probability of A, then these are independent events. It doesn't matter if we know that B has occurred. Right? So if we're thinking about this in the context of our example, let's say if the probability of being older than 55 is the same as the probability of being older than 55 given that they want marijuana legalized, right? I'm just writing this out, kind of the definition of independence in the context of my example. Right? If this holds, right, then I know that they're independent. If it doesn't hold, so here is if that holds, they're independent. If it doesn't hold and they're not equal, we would say that they are dependent or not independent. Now, the way that we kind of have this here, looks like there's one of those right there, right? anytime we're checking for independence, remember, it has to be at the probability of the thing on the left side of our conditional line. That's what we're still looking for the probability of. So this first part of my conditional probability should match up with whatever that unconditional probability is. So this one makes sense. I don't know if it's the correct answer yet, but at least it makes sense. Well, here I'm comparing the probability of LM to the probability of O. Well, that doesn't make any sense. I have to be comparing the conditional and the unconditional probability of the same event. So right away we could rule out B. Here, same thing. We're comparing two different events. That doesn't make any sense. And then down here, we're comparing two different events. We actually can rule out every single answer here without actually even checking with the numbers, right? Now, what if I instead had, flipped one of these so that we actually did have to check it? So maybe I was doing down here, oops, maybe something like this. And so now there are two viable answers, right? How would I actually check it here? In the original, we could rule it all out, and we know that A has to be the right answer. But how would we actually check it if we had multiple answers that kind of made sense for checking independence? Well, what's the probability of being older than 55? Go up here, older than 55, 0.25. I'm not on the screen. So 0.25. What's the conditional probability? Well, we can't just get the conditional probability directly from the table, but earlier, let's see if I have it over here, right? We'd actually solved for a conditional probability already. In fact, just to save us some work, I actually already solved for this conditional probability, right? The probability someone's older than 55 and wants marijuana legalized. So I know this equation would give that to me. I could go on the table, look up these values. I end up finding that probability is that 0.212, which we rounded to 0.21. They're not the same value. So we say, no, they're not independent because this conditional probability of O is not the same or not equal to the unconditional probability of O, or being older than 55. Okay? So this is a situation where we can use some of the previous work we did to actually save us a little bit of time as we're working through this exam. Okay? Any questions on that? No, that one's a little tough. Oh yeah, this one? So this was where we said this is an additional check. This would be, to me, if I didn't have a multiple choice where the answers were given as the actual definition of independence, using that special condition, if this was a short answer question, probably the easiest way is to check it using this, right? Because all these three components are very easy to grab from that contingency table pretty quickly. Okay? And then if that equality holds, they're independent, but in this case where they don't, then we would say they're not independent. Any other questions on that? You want to see something again there? Or, these aren't for me. These are this week is for you guys. So I don't care what questions we ask or what we work through. So I have an idea about what would be good to go through since I wrote, I'm writing the exam. But okay. All right. Let me move this out of the way just for a second so we can actually kind of work to the next set of problems. So I think I'll save this for Wednesday's class just to make sure. We already got 30 minutes out of the way, so I want to make sure we spend a lot more time on this. So we'll kind of return to 10, 11, and 12 on, and actually 13 as well. We'll return to those on Wednesday. Kind of do some probability stuff today, some probability stuff on Wednesday, so we're not, it's not all in the distance feature. So here's what I think are probably some other easy points in this exam if we actually work through the practice exams and we've been kind of keeping up to date in the class, right? So here I've got a discrete random variable where I can see kind of the number, what is this? The number of weeks someone gets sick in the week of February, right? So this becomes easy because there's only 4 weeks in February, exactly, right? So I either get sick 0 weeks. If I get sick during the first week, well, I've been sick 1 week, 2 weeks, 3 weeks, or 4 weeks, right? So I can only be sick for these different number of weeks. I thought Wednesday was yeah, so it's a study day. You don't have to watch the video. I'm recording the video on Wednesday. If you want to watch it on Thursday, that's fine. If you want to watch it on Friday, that's fine. I'm just going to be doing some additional work more than I have to. I'm supposed to not do anything, but don't tell anyone because, you know, I don't actually care putting a little bit more out there for you guys. You know, if you want to make sure that I don't do it, I guess I don't have to put it out there, but no, so I'll be putting it out on Wednesday. It doesn't mean you have to watch it Wednesday. You can watch it Thursday, Friday. Honestly, you can watch it Saturday or Sunday before you take that exam, okay? It's just me working through some more of these problems. Does that make sense?
Yeah, that makes sense.
Okay, so it's not gonna have like an online quiz or anything like that related to that. Okay, so here we've got the different number of kind of weeks we could see, right? And the probabilities associated with each one of those. So what's the expected number, or i.e. the mean number of sick weeks someone has in February? Right? Well, I can't simply add these up, 0 plus 1 plus 2 plus 3 plus 4, and then divide by the number of numbers 5, because some of these outcomes have very different likelihoods of occurring. So we said when we have these discrete random variables, it's actually like a weighted mean, but a little bit easier. So if we look at our formula sheet, and the formula sheet, I kind of tried to write it in terms of like the chronological order of what we did in class. So we get down here, kind of see the newer stuff, right? Here's the Poisson, here's some binomial. Here's just the general form of my discrete random variable, mean and variance. So to find the mean, all we do is go through of a discrete random variable, take each outcome, multiply it by the probability that outcome occurs, and then add them all up, right? That's what that sum sign means. Now, we should have to divide by the sum of our weights, which are probabilities, but we said if we add up the probability of every possible outcome, that should just add up to 1. So it doesn't really affect anything, so we don't write it in here because why complicate things? So if I look at this, what I'm going to do is I'm going to go through every single outcome. So the very first outcome is 0. Multiply that by the probability I see a 0. Add to that the next possible outcome, value of 1, times the probability I see 1 occur, plus 2 times the probability 2 occurs, plus the next outcome of 3 times the probability 3 occurs, plus the next outcome of 4 times the probability that 4 occurs. Right? I think this is 1.05, but I could be wrong. So let me actually get this into my calculator. So 2 times 0.15 plus 0.3 plus 1. Just to double check myself. Yeah, so sure enough, if we get this entered into our calculator correctly, we should get that mean expected value of 1.05. Okay. Are there any answers up here that you think that would make sense you probably could kind of rule out? Right? Well, I don't know. I mean, if I'm thinking about these, if I'm trying to push the kind of principles of this, if the mean were actually 2, it would have to be that outcomes on either side of 2 have to be equally as likely, right? Or would be weighted equally. Well, if I look here, the outcomes above 2 are much less likely than the outcomes below it. So I probably know that that mean is going to be somewhere below 2. So I'm probably pretty safe to rule out 2 here, even if I'm not able to like think exactly what the numbers in this formula, like I haven't put it in my calculator yet. 0.2, theoretically, it's could be possible. I mean, 0 is a very likely outcome here, so it's really going to pull that mean downward. But I mean, it's not like the probability of 0 is 0.8 or 0.9, right? So at 0.2 probably doesn't make a lot of sense. If I'm trying to guess here, I'm probably going to throw a dart at B or C if I don't actually have like a calculator or can't do this math in my head. Any questions on that one before we keep moving ahead here?
I just have another question. You said that you were gonna post like how you do or how like the work for all of these questions before the test.
So for the ones so we'll work through all of practice exam A. So I'm not going to put out like a file of that, but we'll have worked through everything in these videos. So if you're following along in the videos, you should have all the work for practice exam A.
Okay.
I'll put out an additional answer key for practice exam B, and it's all going to be typed out. So, you know, it's not quite as probably useful as having me kind of having some audio to go along with it. But I will post an answer key to practice exam B that has kind of typed out or the formulas or the functions that you use to solve all of those. Yep.
Okay.
Yep. All right. Any other questions before we keep moving here? Are we on time? All right, we're good. So here's one where, because some of these problems are kind of cascading, if I want to calculate the standard deviation, or if I had asked you for the variance here, well, what do I need to calculate the variance? I first need to know what the mean is, right? The variance is some measure of like the deviation from that mean, right? Or how far away most outcomes are from the mean. Well, if you got 14 wrong, then you're sure as hell going to get 15 wrong, right? So I'm going to start everybody off on the same kind of level and say, okay, assume that the value you found in problem 14, that this average number, the mean number of sick weeks is 2, right? So now if I'm calculating the standard deviation, I go to my formula sheet. I've got that discrete random variable variance equation. I'm going to take every single outcome, subtract that mean, which I've been now told, assume it is 2, right? It's also going to make the math a little bit easier for you, right? So subtract that mean of 2, square it, then multiply it by the probability you saw that X outcome. Do that for every single possible outcome and add them all up, right? So what that's going to look like right here, we've got that mean of 2. Well, first of all, which of these answers can I rule out right away? Yeah, the negative one, right? If I'm looking for a variance or a standard deviation, I know it has to be positive. So I know that B doesn't make any sense. Right? So I go back up here. The other 3, I can't really determine which is right unless I actually work through this. Okay? So I'm going to take each outcome. So the very first outcome is 0. I'm going to subtract that mean that we were given of 2. I'm then going to square that deviation and then multiply it by the probability I saw 0 sick weeks. So times 0.54. Then I'm going to add to that the next outcome of 1, subtract that mean of 2, square it, multiply that by the probability I see that outcome of 1 occur. Excuse me. I'm then going to do this for every single outcome, right? So I'll write this out, but I'm not going to kind of keep saying this, otherwise it'll take me a little bit longer to get through this. So probability 2 occurs, 0.15, 3, oh, why did that, sorry. What should I have subtracted here? Yeah, 2, sorry. I was talking, and sometimes talking and writing, it's a little bit easy to make mistakes here. And then the last outcome of 4 minus that mean of 2, probably that occurs as 0.05, right? So from here, it's just a matter of getting this all entered into my equation, right? Now, I could do this line by line. I think the one time in class I said, if you wanted to write next to this or kind of create your own column, you could actually do what? 0 minus 2, which is 2, squared is 4. 4 times what? 0.45, just below 2. So I could write down 1.8. And then I could do the next line. I could do this, the intermediate steps and then add them all up if I don't want to write this whole formula out into my calculator. So that's kind of another way of kind of preventing yourself from making parentheses mistakes or something in your calculator. Okay. So I think if I do that, I'm going to guess here. I think it's that. So let me say, so we got 2 squared times 0.45 plus 0.25 plus 0 plus 0.1 plus 4 times 0.05. Okay. So if I can enter this in my calculator, I get 2.35. Okay. Now, that's my answer, right? What did this problem actually want? The standard deviation. The equation that I just used and that I have in my formula sheet, let me get this out of the way for a second, was for sigma squared or the variance, right? So if I want the standard deviation, it's the exact same process, but what do I do to that 2.35? That's my variance. To get the standard deviation, I just square root, right? To go from the variance to the standard deviation, we're going from, right, here's our variance, here's our standard deviation. So if I want to go from the variance to the standard deviation, I'm I'm just taking the square root. So square root of 2.35, well, it has to be a smaller number. I'm going to go ahead and guess that it's 1.53 if I put that into my calculator. Okay. Any questions on that? Kind of one of the things on the exam is a little bit different is, making sure I'm giving you an assumed true mean so that we're all kind of starting off on the same foot. Okay. So you don't have cascading errors. Any questions on that one? Yeah.
2.35 would be the variance.
Yep. Yep. So that equation that we had in the formula sheet, that was for sigma squared or our variance, right? We wanted the standard deviation. That's just sigma, so we had to take the square root, right? That one additional step. Any other questions on that one? Okay. So this next one, don't overthink something. Right? Sometimes I see people overthink. So there's going to be a couple things that are a little tricky with this that we have to think about, but for the most part, it shouldn't be too bad. This should be a fairly easy when we get to the exam, right? So what's the probability that someone is sick for less than 2 weeks? Right? So the probability that X is less than 2. If I go up here, right, what's the probability that someone is sick for less than 2 weeks? Well, I could write this out, kind of be real formal about it, which is that I want the probability. This is, we didn't really do this as much with kind of the general discrete random variables. I focus more on the binomial and Poisson. But if I think about this as event A, the probability of A is just the probability of each outcome that's in that event, right? Because I can't see someone be exactly sick for 0 days and exactly sick for 0 weeks and exactly sick for 3, right? There's no kind of overlap there. So I'm just looking for the probability of each outcome in this event A. So what's the very first outcome I could see that meets this criteria? Probably that X is. So I'm not looking for the probability. So you're jumped one step. I'm not asking for the probability, what this probability would be. What's the first outcome I could see that's less than 2? Well, 0 is one of them, right? But the very first one would be the probability that X is equal to 1. And then I add to that the probability X is equal to 0, right? I'm just writing the probabilities of the possible outcomes that meet this criteria. The only two outcomes that are less than 2 are 1 and 0. Now from there, the probability X is equal to 1 was 0.25. The probability X is equal to 0 is 0.45, not 0.6, 0.7. So what I'm doing is I'm just thinking about what outcomes fit this criteria and then just added the probabilities of those outcomes. So the only outcomes less than 2 would be 1 and 0. And this is where we have to be careful with equalities, right? If I said, what's the probability someone's sick for 2 weeks or less, or X is less than or equal to 2, right? Well, if I had the equality on here, well, now I have one more possible outcome, right? X could be 2 now, right? Then I would add the probability of 2 was what? 0.15, and so then I would have had 0.85. So, be careful with the equalities on a question like that. But we're really just looking for, if I have a, not just the probability, where was it, of one outcome, but kind of a range, right? Less than or greater than. Think about which outcomes are in that event, right? Meet that criteria. Find the probability of each one of those outcomes and just add them up. And with a table like this, right, it's pretty easy to find those two probabilities and add them up. I didn't have to use an equation like a probability mass function or anything like that. What if I wanted the probability that someone is sick for 3 weeks or more, right? So the probability that someone is sick for 3 weeks or more, what are the two possible outcomes that fit this criteria? X could be, so I didn't put less than or equal to 3. I put greater than or equal to 3. So what are the only outcomes that fit that? So yeah, X is equal to 4 and X could be equal to 3, right? So then 0.04, 0.1 from the table, yeah. So be careful with that equality. Be careful, like, kind of like that you fell victim to a little bit, right? Making sure I'm thinking about, is this greater than or kind of less than that value, okay? Any questions on that? I think like the furthest I would push something like this, I wouldn't, I probably do that. All right, we got a couple minutes left. Let me think. We could start the binomial, but I've got a few more problems. I actually want to go a little bit more in depth into this one. So we'll just do a review here and we'll kind of pick up on this next class. So let's say, well, I've been typing stuff in here, so now everything's all wonky, but let's go down to problem 17 now. We just did 16, that was what? Kind of following, we have 0.7 there. You have the answer key, but just to kind of highlight the answers we've been coming up with. So let's say instead I've got this example where 64% of Americans have a visual impairment and they need, contacts or surgery or something. So suppose that we select 15 people at random, right? What's the expected number of individuals who are visually impaired? Now, first of all, which of these which can you rule out right away? If 64% of people on average have a visual impairment and you're looking at 15 people, what's the expected number of people who are visually impaired? Which of these doesn't make any sense?
D.
What would the probability that someone has a visual impairment have to be in order for D to be the right answer? 100%, right? 100% of people would have a visual impairment. So right away, we've really only got 3 answers. Right? Now, 64%, right? That's my probability. If I ask any one person, the probability they had, visual impairment is 0.64. And then I'm looking at 15 people, right? So if I go to my formula sheet, down here at the bottom, they're even grouped. I have my binomial equation. So here's my probability mass function. Here's how I find the mean for a binomial distribution example. Here's how I find the variance, and then the standard deviation, right, which is just the square root of the variance. So here I have the equation for the mean, which is simply n times p. I said my probability of success of any one person would have been, a new sheet of paper, 64%, so that probability would be 0.64. I'm looking at 15 people, so it's simply 0.64 times 15. I'm going to tell you right now, I'm not even thinking about this or doing the math in my head. I know this is 9.6 just from the given answers. Because if I think about this, right, if 64% of people usually have a visual impairment, if I asked 100 people, how many would have a visual impairment? 64, right? You did 100 as your n times that probability of success of 0.64. Well, here, if I know the probability is 0.64, if I use that 0.5 as kind of an easy, like, put a bounds on it, well, this is greater than 50% or 0.5, so I know that more than half of the people should be expected to have a visual impairment. So I know the correct answer should be somewhere above 50% of 15, which would be, what, 7.5? So I know the answer should be somewhere above 7.5. If I look at the possible answers, A is the only one that meets that criteria, right? So, I can actually go ahead and enter this in my calculator just to be safe, but I'm trying to talk through these ideas so that when you get to the exam, if you do get stuck or you're like, man, something, I don't know, maybe you're having issues with your calculator or something, you can still kind of think through and kind of help yourself out, right? And this one, you shouldn't have issues with your calculator. I was thinking more of like if you're having parenthesis issues with a harder problem, but just trying to talk through as much of this as I can with you guys, okay? So Wednesday when I record the video, I will work through 18, 19, and 20, and then I'll go back and work through 10 through 13. I'm guessing I can get through all that in about 50 minutes. And then Friday, I can go over the first 4 problems. They're not near as difficult. So what I'll probably do is just kind of leave it more open-ended Friday to where if you have questions, you can ask me if you want to rework through specific ones, or even like an old online quiz question or an old homework question, anything like that. Okay. Any questions before we kind of get out of here? All right. So you don't have to show up Wednesday. If you want to, I'll be here just recording. I'll have the Zoom link open. If you do want to sign on, you're not expected to. But I'm just going to put out that video as an additional resource Wednesday. You can look at it Thursday or Friday or whenever you want to before you take the exam. Okay? All right. Well, I'll see you on Friday, or if you decide you want to just watch me record for fun and not expect to do it Wednesday, I'll see you then.